All right, let's talk a little bit about zeros of polynomials. One thing we want to know about zeros is that imaginary zeros and radical zeros come in pairs. Whole number values, rational ones, may not come in pairs, but whenever you see that a polynomial has a zero like 2i, then you know there's also going to be a polynomial or another zero at negative 2i. Having a zero of 6 doesn't necessarily mean that negative 6 is going to be a zero, but since we know that 2i is one of the zeros, negative 2i will also need to be a zero. So the zeros of this polynomial, if it's degree 3, are going to be 6, 2i, and negative 2i. That's because the complex ones come in pairs. If a polynomial has degree 4 and has a zero at radical 3 and 4 minus 5i, we know that the radicals and the imaginary ones come in pairs. So for our zeros, we know radical 3 is 1, so negative square root of 3 also has to be a radical. If you think about when you do the quadratic formula, you almost always get these in pairs. Now I want to talk a little bit about this one. We know 4 minus 5i is a 0. The way we find the other one is slightly different. All we do is we change the I term. We flip the sign on the I term. So the other 0 would be 4 plus 5i. So again, we know that the imaginary ones and the rational ones are the zeros that come in pairs. So the irrational ones and then the imaginary ones. Rational ones are whole number ones. Fractional ones do not come in pairs.